Okay, in this video I'm going to talk about solving quadratic inequalities, and this will be the first example. And the basic idea is you make your inequality into an equation. You then find the solutions of that by either completing the square, you can factor it, you can use the quadratic formula. And from there we'll make a number line, putting our solutions on the number line. We'll check those solutions in the inequality as well as a point from each interval. Okay, so suppose we have x squared plus 2x minus 8. Okay, I'm going to factor this. Well, first we'll turn it into an equation. So x squared plus 2x minus 8, we'll just make it equal to 0. Okay, and it doesn't matter what your inequality is, just make it equal to 0. And then I think we can factor this one. So let's see, we'll have x and x. We need two numbers that multiply to negative 8 but add up to positive 2. Well, I think positive 4 and negative 2 would do that for us. So we'll get negative 8, and then we'll get our positive 2 in the middle, equals 0. So then we set each piece equal to 0. So we'll get x plus 4 equals 0, or x equals negative 4. We'll do the same thing with the other part, x minus 2 equals 0. So if we add, we'll simply get x equals 2. Alright, so now I'm going to make my number line. Okay, I'm going to put these points on there. I'm going to put negative 4 down, and then I'm going to put positive 2 on there, and those are the only numbers I'm going to put on my number line. Okay, so let's look at our inequality. And you could even factor your inequality, which would be the exact same thing. We would have x plus 4 and then x minus 2 greater than or equal to 0. Okay, and I like to think about it in its factored form. I think it just makes the arithmetic a little easier, honestly. Okay, so we have to check each point. So, well, let's do that. So we have to check negative 4. But again, if I check negative 4, let me use a different color, maybe one that'll show up a little better. So we have to check negative 4, but notice if I plug negative 4 into my inequality, it would be equivalent to plugging it into the second line here. So we would get negative 4 plus 4, which is going to be 0. Negative 4 minus 2, well, is that greater than or equal to 0? Well, on the first part you get 0. Well, 0 times anything is 0, so certainly 0 is greater than or equal to 0. So I'm going to shade it in to indicate that that point works. And the same thing, if you plug in 2, you know, from our first, what we did at the beginning, we basically said, we figured out what values give you 0. If you plug 2 in, we're going to get 0 out, and again, 0 is greater than or equal to 0. So if your inequality is greater than equal to or less than equal to, the solutions will always work, okay? Because those are the things in particular that give you 0. So now we simply have to check a number from each interval. We have to check a number smaller than negative 4, in between negative 4 and 2, and then we'll pick a number bigger than 2. Pick any number that you want. So maybe I'll plug in x equals negative 10, and I'll check that. So I'll get negative 10 plus 4, and then I'll get negative 10 minus 2, and I'm asking myself, is this greater than or equal to 0? If it is, that means every number smaller than negative 4 works. So negative 10 plus 4 is negative 6. Negative 10 minus 2 is negative 12. Is that greater than or equal to 0? Well, a negative times a negative will get positive 72. Positive 72 is certainly greater than or equal to 0. So that means everything less than negative 4 will be a solution for our inequality. So that part certainly works. And this is why I like to have it factored, because I usually don't even go through, you know, I can recognize, and this is how I try to get people to think about it, just as a time saver really on a test. If you take something, say, negative 10, I think you can convince yourself the first term is going to be negative. The second one will also be negative. Well, a negative times a negative is a positive, and a positive number is always greater than or equal to 0. But let's just keep checking. Let's just be do it the long way here, really check everything thoroughly. So I'm going to take a number between -4 and 2. Well, 0 is in that interval, and usually that makes the arithmetic easy. So if I check x equals 0, well, in the first part, 0 plus 4 is just 4. 0 minus 2 is -2. And I have to ask myself, is that greater than or equal to 0? Well, again, you're going to get a positive times a negative. We're going to get -8. And -8 is not greater than or equal to 0. So that means the stuff in the middle doesn't work. And lastly, let's take a number bigger than 2 and see if it works. I don't know, maybe we can simply plug in x equals +10. So if I plug in +10, I'm going to get 10 plus 4. 10 minus 2. Is that greater than or equal to 0? Well, I'll get 14 in the first part. I'll get 8 in the second part. Again, these are both positive, so certainly this is going to be greater than or equal to 0. So that means stuff bigger than 2 also works. So a couple things to point out. One, if you have two distinct solutions like we do here on these quadratic inequalities, one of two things will happen. Either the outside parts will work or the inside part will work. Okay? That's one thing. Let's write our solution here in interval notation. So I could write my solution in interval notation. So it would be everything from -infinity up to and including -4, so I would put that in brackets. And then union, we can also include stuff starting at 2 up to infinity. So that would be my solution set. And that's it. That's the basic idea on how you can go about solving these quadratic inequalities. And really inequalities in general, this is what you do. You try to figure out where it equals 0, where it's undefined, if that happens in your particular, it'll never happen for a quadratic inequality, but for just maybe a weird function, this is what you do. You figure out where it equals 0, where it's undefined, make a number line, and it gets tedious because you have to check each interval as well as the points. But alright, I hope this example helps. I think I may try to do a harder one too, so stick around and look for that one if you need it.